Hello class, receiving students and teachers. Thank you, may be seated. Now, recapping on your previous lesson, what did you learn or do in your previous lesson? Receiving students, what did you learn or do? Class, can I have somebody to tell me what you did or learned in your previous lesson? Shannon.
Uses of simple machine.
Uses of simple machine. Uses of simple machine. Right, good. You looked at uses of simple machine. Now, what simple machine did you look at in that lesson? What were the examples of simple machines that you looked at in your previous lesson? Receiving students? Class? Donald.
Levers, pulleys, wedge, wheel and axle, inclined planes, and screws.
Okay, good. There were about 6 different simple machines you looked at in your previous lesson. Now, all those were simple machines. They made they helped to make our work a lot more easier. Now, you looked at pulleys, wheel and axle, inclined planes, wedge, levers, and screws. These are all 6 different examples of simple machines that we can see around us. Like pulleys, for example, the one that you saw on pulleys, you were doing an example of a pulley in your previous lesson. An example could be a flagpole found in your schoolyard. That pulley helps the flag to be raised up and down the pole. And wheel and axle, we see it mainly on trucks and vehicles with wheels and the axles going around them. Inclined planes, we find that mainly on ramps or seesaw or slides found at the, not seesaw, but slides found at the playground. Wedges, most common example would be those at the sides of the axe or knife or chisel. Okay, those are examples of wedges, levers, scissors, crowbar, and of course screws to screw things on. Very good. We looked at different examples of simple machines. Right, receiving teachers, we are on the same strand, science in the home, and the same sub-strand. Our learning outcome is still on 3.5. And it's Unit 8, Everyday Simple Machines. Our topic for today is on how can we make work easier. And of course, this is lesson number 88. How can we make work easier? We already saw examples in the previous lesson. Now, I would like you to tell me how you can make work a lot easier for you. Receiving students? Class, can somebody tell me how they can make a work or some sort of work a lot easier? Emmanuel. Emmanuel, receiving students, you may tell your teachers as well.
By using the simple machine.
By using simple machines. Very good. We already saw those examples that were given. Now, in your previous lesson, you were looking at one simple machine, and that was the... What was the simple machine you looked at in your previous lesson? Receiving students, what was the simple machine you looked at together with the model class? The ramp. You looked at the ramp, did you? Okay, you looked at a ramp, and what else? Now you looked at a ramp, and of course you looked also at pulleys. In today's lesson, we are going to be looking at another simple machine. Good. You probably looked at this in your first previous lesson. Today we are going to be looking at levers. We will be looking at levers in our lesson for today. In your own words, what are levers? What do you think a lever is? Can somebody tell me what you think a lever is? Somebody? Anybody? Know what a lever is? Carl. Good.
A simple machine which turns about a fixed point called the pivot or fulcrum.
Right, Carl thinks a lever is a simple machine which turns about a fixed point called the pivot or fulcrum. Very good. A simple machine which turns around a fixed point called a pivot or fulcrum. Okay. That is an example of a lever. Now, take a look at this. This object here, this object, and probably, of course, this object here. Now, these are all rulers. This is also a plastic ruler, and this is the box of the plastic ruler. Now, a lever, what it says is a simple machine that moves about a fixed point called a fulcrum or pivot. Now, if this is a lever, if we were using this as a lever, then it moves about a fixed point, somewhat like that. If this becomes a fixed point, then the lever moves about it. It moves about it. Take, for example, a seesaw. Very good. A seesaw is an example of a lever. On a lever, let's say a seesaw. There are different parts on a seesaw. There you can see there's a place where when someone is sitting down on the seesaw, two people are. One and two. On the lever itself, there are certain different places there. Say, this one here. This is a this is a fat person compared to the other one. If this person is fatter than this person, then where he sits determines how the seesaw will go. Which way will you think the seesaw will go? Towards the left or right? Towards your left. And that is towards the person sitting on this side, this fat fellow here, or bigger weight than that. And so the seesaw moves in. Maybe the seesaw goes this way because of the weight of this person on this side. Like that, because of the weight of the person on this side, it makes that bit unbalanced. Okay, what we're going to look at today is that on the lever itself, there are different positions that we can find. There are different positions that we can find on the lever itself. Now, where the person is sitting, where this person is sitting here, this fat fellow, there is a name for this position and a name for this position and a name for this position. Okay, the fat person sitting has a different name for that particular position on the lever. So in today's lesson, we will be looking at different parts of a lever, different parts of a lever. And we will be using the words like effort, load, pivot. Right, we will mainly use these three words. Looking at that picture, now class and receiving students, I would like you to look at this picture here. Can you see that picture? Okay, good. Where is the effort? Can anyone tell me where the effort is? Effort. Where do you think the effort is on the seesaw there? Somebody? Isaac. Now, receiving students, you may also tell your teacher, where do you think the effort is? Now, who is creating more effort? Isaac?
The right side.
The right side. The right side meaning which particular person or thing?
Person sitting down.
Person sitting. Okay. Isaac thinks it's the person sitting there with the yellow shirt. Okay. Is that an effort? Okay, let's see where the effort is. Now, if we said that other person on the other side, then that is the effort. He is trying his effort to try to balance the seesaw. So, it is the effort. The person with the red shirt is applying an effort, trying his effort to balance that. Now, same one. Where do you think is the load? Obviously, the load becomes the person in the yellow shirt. Okay, so that will be the load. Here's the load, so it is heavier. It's got more load. Okay, so that is the load. And where is the pivot? The pivot will obviously be in the middle there. Okay, the pivot is just above where that where the seesaw is. See this? This is the fulcrum, but the pivot is up there. That is why it is on a fixed point, moving up and down. The pivot will be up there. where that seesaw comes and rests. Right, good. So all in all, we can see on the lever there is the effort, the pivot, and the load. Those three main things on a lever. Simple example of a lever. Right, you quickly write down that into your notebooks, receiving students, where the effort, pivot, and the lever are located. Get it down quickly. You got that? Good. Now we will go into our activity. We will go into our activity. Right, you got that down? Okay, before we go into our activity, let's look at an example there. This example. Do not worry about moving the position. Let's see on the picture there, you can see a girl standing there and letters there. A. She's trying to balance that bit of weight there. Okay, A. From there, can you see from the center to the other side is also another position. What do you think that position is? The distance between the middle part there and A. What do you think that distance will become? It is a distance. What will that distance be called? What do you think is the distance from here and the distance from here to there? This bit here. Receiving students? Okay, let's hear from Donald. Donald, what do you think that distance is called?
Load.
Load. Good. Okay, that's the load. You think that is the load? Yes. Load. Right, the load is here. This is the load. If this is the load, then what do you call this distance? Is the question. This is the load. This is not the load. Very good. This is not the load. This is the load. This is a distance. What is the name of that distance? What do you think the name of this distance is? Okay, if you said here, that distance there, if you said it's a load distance, then you are correct. Okay, so that is the load distance. The load is here, and that distance there is called the load distance. Now, how about from the center and to that center here, this center. This center, the right at the center. That will be the pivot. Very good. Okay, so that will be the pivot. B is the pivot. B is showing the pivot. Okay, C. C is from the center and this end here. Then that becomes the, very good. By now everybody should be calling out. Good, that is the effort distance. That is the effort distance. So we have the load distance, we have the effort distance. At this end here, this girl is putting on where her fingers are, hands are, that is the effort. Where this is hanging, it is called the load. The distance from the center pivot to there will be the load distance. And of course, there to there is the effort distance. Very good. Okay, we are going to do something similar to that. Now, let us see the first picture. You can try that out. The first one. Move the position of the pivot. First of all, if you have rulers there, you may use your rulers and put that at the edge of your desks. Or for the model class, you put that at the edge of your table. You put it that way so that you may have, try to find a load or bilum or such that you can do. For a model class, we are going to be using what we used first. Okay, so we will use this bit here and use this as the pivot, this one here. You may use a pencil or saw as your pivot, or a book, or rubber. Now try to put a load at the end of the ruler, your rulers or sticks. Receiving students, if you have sticks in your classrooms, you can use those sticks. Put that on the pivot, and then you try to put a load at the end of, the lever there. Right, once you have done that, you are going to move the position of the pivot. Move the position of the pivot. Move the position of the pivot so it is balanced. Right, when you move the position of the pivot, those who are doing it with smaller rulers too, you move the position. If you move the position of the pivot, what do you feel? What do you feel when you are moving the position of the pivot to, say, to the left? What do you feel on your fingertips there? Okay, when it is like that, what do you feel? Okay, let us hear from some of the students here. When this position of the pivot is moved, the center there, when you move the position of the pivot towards the effort side or towards the load side, which one does the more work? Meaning, what do you feel? On which side of the lever do you feel more weight on your fingertips, if you are using your fingertips on a small ruler, or on your hands? Which one seems to be having more load? When you move the pivot or center towards the effort, or when you move the pivot towards the load? Which one seems to do more work? Cullen.
Towards the load.
Right, Cullen says towards the load. Now let us see an example from here. Let's see if he is correct. Okay, if this is this will become our load. Now that is our load. If we move it there, Cullen, come. Okay, Cullen is going to help us by answering that question. Right, the pivot is here. Now I am going to move the position of the pivot towards the load. I am now going to move the position of the pivot. I am now going to move the position of the pivot towards the load. This is the load. Okay, Cullen, how do you feel at the end there?
Less heavier than the light.
Less heavier than light before. Okay, less heavier than before. Good. So moving the pivot or center towards the load makes it less heavy. So he's able to do easier work. Yes? Yes. Very good. Now if you move it back this way, what do you feel now?
Heavy.
Heavy. It is heavier, so he will need more effort. The work is more harder. then moving the pivot towards the load makes the work easier. Okay, good. That is one. Thank you, Kalen. Now, second one. Now the second one. The second one that you are supposed to do is you will move the position of the effort. What if you move the position of the effort? The pivot stays. The pivot stays, and you move the position of the effort. You move the position of the effort towards the center. How does it feel when you move the position of the effort towards the center? Now with that, I will again ask my assistant, Kalen, please come to the front. This time we are not going to move the position of the pivot. This time, Kalen is going to move the position of the effort. Now, receiving students and class, where do you think the effort is? Here or here? Okay, the effort is here. That is where the effort is. Now, what he is going to do is he is going to move his position here. The pivot stays. We'll do that again. The pivot stays, and he's going to move his position there. Okay, so he will remove his hands and put that there. Right, he will tell us what he feels.
Balance.
Okay, it is balanced. It feels as if it is balanced. Are you doing a lot more work or little less work?
Less work.
Less work. Less work than when his hand was here. Okay, so what Kalen is saying is, when his hand was here, he was doing more work. Now, when he moved his hand effort here, then it's less work. Effort closer to the pivot. Very good. And the last one. Last one, we have moved the position of the pivot already, so that has already been done, moving the position of the pivot. The last one, we are going to move the position of the load. Okay, so Kalen, hold on to that. And his effort is still there. While he's doing that, you can do that with your little rulers there, receiving students and class. You can also try that out with your rulers. Okay, I will now move the position of the load. If I move it closer to the pivot. Kalen, are you doing a bit less work or more work?
Less work.
Less work. When the load goes closer to the pivot, he says that it is less work than when it is away from the pivot. Thank you very much, Kalen. Right, you can also try that. You will see that the more you move closer to the pivot, the less the work becomes. Okay. Okay, our summary for today. A lever is a bar or stick which moves around a fixed point called a pivot. The next one, levers can make work easier for us. Very good. By now you should have completed your summary notes. Our key phrase for today, key phrase, making work easier. Making work easier is our key phrase for today. Next lesson will be on the night sky. Now, receiving students and class, for the next lesson, ask your grandparents or grandfather, ask your mothers or fathers for a legend you know about the night sky. Now, materials needed for that lesson, pictures, charts, and pencils. With that, thank you very much, class and receiving students, and have a nice day.